Hello. So let's see if we can get one image turned into a series of graphs. So to get started, we're going to import the image, clicking here. We're going to select the image. And then by clicking on it, you can resize it and try to have a size that will allow you to have decent numbers. So if you want to zoom out, and you can just click on it and get it as big as you want. Once you have the size, you can bring back the toolbar and start working on your equations. One thing that you need to consider is that you must foresee what kind of functions and equations you're going to be needing, and considering the fact that you're going to need all four conic sections, you're going to need logarithmic, exponential. So try to see before picking the image or while picking the image that you will be able to produce those functions and those equations. Usually the more used equation is the circle or the ellipse, the parabola. If you know how to sketch a circle, you pretty much know how to sketch an ellipse. So let's write the equation of a circle. And I always start by writing the center at the origin. So I write x minus 0, then plus y minus 0 squared, and with a radius of 1. If I divide everything by 1, or this is actually 1 squared, if I divide everything by 1 squared, this will turn into an ellipse, and under each of those things, under the y's, under this binomial, and under the x minus 0 squared, you can have the length of the circle horizontally and vertically. If you want to alter the horizontal length, you're going to do it under the x. So this will alter the horizontal length, and this value will alter the vertical length. So basically, an ellipse is one where you have both the horizontal and the vertical length the same. And once you have a circle written in this form, you can start working with the ellipse. And it looks like the shape that we have at the bottom of the face is an ellipse. So it's just a piece of the ellipse, so we're missing part of it. But if you do a rough sketch over here, it looks like there's an ellipse somewhere around there. And the center of that ellipse might be somewhere on that point, around that point. So we're going to start looking for the center, and then we're going to be adjusting the horizontal and vertical length. So the center looks like we only need to change it vertically. So you can start to play around with some values. If you use a negative, it'll move up. So let's use a positive. Looks like we need to be a bit lower down. And then you're going to start to play around with the horizontal length and vertical length. So the horizontal length is not the entire length, it's from the center, just like the radius from the center to the edge of the circle right now is 1. So if you want to change it to 2, from the center to the edge of the ellipse will be 2 units. If you notice, this is the center and we're 2 units away horizontally to the edge of the circle. So you can start playing around 3, looks like it is too much, so let's say 2.7. And now you're going to play around with the vertical length. So now we're going to change it to 2. It is perhaps too much. Let's try it with 1.9. Still too much, 1.8. Looks like we're onto something. So I'm going to get rid of my sketch. And now that I have the ellipse, I'm going to restrict the domain or the range. If I want to restrict the range, I'm going to write a y. If I want to restrict the domain, I'm going to write an x. So if I want to restrict the range, I'm going to see where the limiting value is going to be. So if I want to limit this, let's say all the way to here, that's as far as the ellipse, this ellipse will work for me. So it looks like it is all the way to minus 0.5. So I'm going to write just that on my restriction. Y has to be less than minus 0.5. So now I only have that segment of the ellipse, and I can keep working with my sketch. One thing that you can do in order to have a better view of your sketch is to click here and then on the left and change the opacity of the image. So you can change it to any opacity that allows you to see your sketch. Once you have your graph, you can also play around with the thickness of the line. So I'm gonna need a thicker line. So you're gonna write it there and I can change the color. I might use black. Now that I have that ellipse, we can start playing around with parabolas. If you notice, you can break down the ears into a series of parabolas, one with vertex here and opening upward. You don't need the whole parabola, you just need a segment of it. You might think of this as another parabola with vertex somewhere around there, and this as perhaps another parabola, a thinner parabola. So we're going to use segments of parabolas, and those look like vertical parabolas. So we're going to start writing vertical parabolas. So a vertical parabola, I always go for the origin at first. I have a 1 over there just to have something other than 0 and y minus 0. So that will allow me to play around with the position of the parabola. So if I want to get this parabola to the position down there at the bottom of the ear, I'm going to have to move the position both on x and y. If I want to move it to the left, I'm going to have to change the sign to positive, and let's say 3, 3.4. So I'm going to play around with the values 3.42, and then the y as well. So if I leave it as negative, it'll move upward, and then let's just play around with the values. 1.1, this is you're gonna get a better feeling of how the parabola moves as you start working on it. Over here, it looks like we need to compress the parabola, and that is achieved with a value that is between 0 and 1 over here. So if I start to play around with decimal values, 0.5, perhaps we need a bit more, 0.4, 0.3, 0.3, 3. If I notice that is around 1/3, so I can leave it as 1/3 or 0.3. Either way, it'll be a good approximation. So I'm gonna get rid of my sketches and I'm gonna start restricting either the domain or the range. In this case, now I'm gonna restrict the domain, so I'm gonna use x. X has to be greater than something and less than another value. So if you notice, my parabola needs to be cut somewhere around the lines of this value and perhaps this value. So I'm gonna try to figure out what those values are. Somewhere before 4 and somewhere after 2. So it's just around those values, but I don't have the exact idea yet. So I'm gonna write -3, then x, and then I'm gonna write -2. So if the values don't make sense yet, I'm gonna play around with those. Let's say -3.7. So I'm getting closer to it, and -2.8 or 0.82. So I'm just gonna use different values to get close to the segment I want to use. And the good thing about this is because it is symmetrical, I can just use that same equation and just try to fit it on the other side. So if I change this to negative, now I'll be shifting the graph, or the vertex of the graph will be on the other side of the plane. And I'm going to use the restriction as well, but now if you notice, I'll have to invert the restriction. I might even adjust the values if I want. It's going to be up to us. So let's say I use 2.8 or 2.81, 82. So it's about playing around with your values. and 3.7 or 3.69. Right now, we just want to see what fits better in our sketch. And all the way through, you can keep changing the thickness of your lines just to have a better view of how this sketch will end up. Now that we have parabolas, we can, I don't know, use, perhaps we can see that we are going to be needing a parabola also, as I said, for this part of the ear, for this part. We might see an ellipse happening here. So I already showed you how to do parabolas, ellipses. So now I'm going to show you how to use perhaps an hyperbola, how to use an exponential, a logarithmic. So if I want to use, let's say, a rational function. A rational function, the simplest form is 1 over x. If I do 1 over x, I'm going to have the two parts of the graph facing in different directions. So if I square it, I'm going to have the Paris version of the rational function. And I'm going to set my equation ready to receive a change or a shifting. So I'm going to write x minus 0 and plus 0. That way I'll be able to shift my graph. And my goal is to hit the eyebrow. So the eyebrow would need to have a reflection of the graph. And which eyebrow do I want to hit? Well, I could hit either one of those. The left one, the right one, is going to be up to us. So if I want to hit the right one, I might have to move this to the right. So that's 1.1, 1.5. If I want to shift it up, I can shift it all the way to 2 or 1.9. So I'm getting closer to the position. And as you know, this will also compress or expand your graph. So if I use 2, 3, 4, so it's gonna change the appearance of the graph, or if I choose values that are less than 1.1, so this is compressing our graph. So, or making it more look like an L if I use tinier numbers like that. So it's a bit more compressed. So if I want to compress it, let's say I use 0.19 like that, and I'm getting very close to the position of the eyebrow. Perhaps I might have to shift it a bit more to the right, so 0.7 or 0.69. It's gonna be up to us how accurate we want this to be. And once I have the shape of the eyebrow, I can restrict the domain or the range. In this case, I'm gonna go for the domain. So it looks like it's gonna be somewhere close to 1 and 0.5. So I'm gonna write those values as a starting point. And then I'm gonna start adjusting the value. So 1.1, perhaps it was too much, 0.9, 0.8, and over here 0.5, I can change it to 0.4. So I have a good approximation. I can still make it better, but you get the idea of how to use a rational function. And if you wanna, once again, adjust the thickness and the color, you have a very good approximation of the eyebrow. Now, there's also the exponential function. There's also the logarithmic function. So those can help you to do the other eyebrow. So let's write a logarithmic function. So I'm going to go to functions over here. I'm going to scroll all the way down until I find the logarithms. And I'm going to choose one that allows me to have different bases. So as to get started, I'm going to choose a base 2. And I'm always going to try to have my equation ready to be shifted. So this is the horizontal shifting and the vertical shifting over here. If I want to change the appearance of the graph, it can be done by a scaling factor. So 2 or 1/2. Or you can also do that by changing the base. That's going to be up to you. The greater the base, if you remember, the first coordinate after the x-intercept is going to be 1 comma the base. So I can push that base to a big number if I want to make it look like this. So let's say I use a base of 200, 250, 100. It's going to be up to me if I want to alter the graph by changing the base or by using a scaling factor out of the logarithm. Now it's going to be about shifting the graph to get it closer to the other eyebrow. So if I want to shift it to the left, I'm going to need a positive number. So I'm going to add a 1 here. And I'm going to shift it up by adding a 2. So that is close, not perfect. So let's use 1.1. So that's a bit better. And 1.9 over here. So it's not perfect, but perhaps I can use just a segment of that graph and then complement it with an exponential, or I can show you how to get it done with an exponential. So I'm going to just use a tiny part of this graph, and you can once again look at the position where you want to cut it. So in this one, I'm going to use a restriction on the range, perhaps. So if I want to cut it using a restriction on the range, it would be something like this. Perhaps I want to cut it from here to here. So I just have to figure out what those values are. So let's go for it. Let's say I go from 1. I always start with some values to have an idea. And because I'm cutting it on the y-axis, I have to write y all the way to 2. That was too much, so I have to make some adjustments. So 1.7, and here instead of 1, let's try with 1.3. And let's get rid of those lines. And 1.3, we can play around with the values. So if you notice, that's not the entire eyebrow. So I'm going to show you how to do it if you perhaps want to use an exponential. So you can write y, and once again, start with a simple exponential. 2 raised to the power of, once again, I'm going to leave it ready to receive any kind of shifting. And because it is not the position of the eyebrow, I'm going to have to use a reflection. So that reflection might be useful for the other eyebrow. But if I want this one on the left, I can use another reflection like that. And once again, I can use a scaling factor, or I can just play around with the base. So if I change the base to 200, perhaps it's going to be resembling a bit more the eyebrow. So 250, it's up to you. Now let's try to shift this to the left. So I'm going to need a positive value. So it might be 1. And I have to shift it also vertically. So we might need a 2. Perhaps it was too much. So 1.8, 1.7. So I have to try to play around with those values. And horizontally, perhaps I need a bit more, 1.2. So it's almost there. And at any time you can zoom in and to try to see where you're going to cut your graph. So from that point all the way to the end of the eyebrow, or I can even substitute my previous sketch of the eyebrow. In this case, I'm going to use a restriction on the domain. So it might be for something around 0.7 all the way to 1.75 or something around those lines, or sorry, 0.4. That was the X value. So let's go for those values, or around those values, 0.71. And because I'm using on the x-axis, I'm going to write X, and all the way to it was 0.4. So I have the other segment of the eyebrow, and I can just, once again, work with the thickness of the eyebrow. So I have 2 different versions of the eyebrows, one using exponential and logarithmic functions, and the other one using rational functions. Now, the rest of the sketch, you might need, let's say, a hyperbola. Where do I use a hyperbola over here? Well, on the face of on this side and on this side. A hyperbola, if you wanna think of it like this, is like two parabolas facing each other. And how do you get started with that? Well, let's get started with an ellipse. And if you want to sketch an ellipse that ends exactly here where I want the hyperbola to start, right here and right here, I'm going to try to get an ellipse of that horizontal length. So I just copied one of the previous ellipses and I'm going to try to go for the hyperbola. So once again, I'm going to start with 1 at the origin, ready to receive any value I want. And I'm going to play around with the x, the horizontal length. So 1.724, perhaps. And I might need this to, I'm going to use 1.2. And I'm going to shift this, or 1.21. I'm going to shift this vertically to have it higher up. So 1, if it is too much, 0.95. And I have an ellipse touching the edges of where the hyperbola needs to be. Now, if I want a hyperbola, it's kind of like an explosion of an ellipse. If I want the hyperbola to explode this way, or if I want the hyperbola to explode in a way, this way, that can be accomplished by changing the signs. If I change the sign of the y, it'll open horizontally or to the sides. And if I make this part negative, it'll explode or open outside of that ellipse, but vertically. So in this case, it looks like we need this to open to the side. So pretty much do an ellipse and then change one of the signs and make it go in the opposite direction of the ellipse. And in this case, because we just want that segment on the face, we're gonna restrict the range. Looks like it is a better option to restrict the range. So I'm just gonna write, let's say 0.7, and I'm gonna use y because I'm restricting the range, and when 1.2. So I have that tiny segment of the face. Now, this is getting a bit messy, so I'm gonna start ordering my equations into folders. So I'm gonna start with the ellipse. So I'm gonna move this all the way to the top, and I'm gonna put inside of this folder every ellipse. That way I can hide them. And then I'm gonna create one for the parabola. So I'm gonna put it here, and I'm gonna write parabola. And I'm gonna start throwing all parabolas and connecting them to that folder. So this parabola, and then I'm gonna hide them. And then I can say, well, I might need some of those shapes later, but right now I don't want them to be on the way. And then rational, and I'm gonna put that in there. Then logarithms. This one goes in there. Then I have an exponential. Over here. That one goes in there. And finally, so far I have a hyperbola. And let's throw this one in there and hide that one. So what else? Well, we need to use a line. So we can use any segment that resembles a line. So this right here kind of resembles a line. So I don't know. I'm not gonna do a perfect sketch of the line, but perhaps I need something like that. So as you know, the line has a slope, positive or negative, and now y-intercept. So I'm going to start by writing a general equation that will allow me, well, not the general equation, but a general thing that will allow me to work with the line. So this one is crossing the x-axis at 0 and the y-axis at 0 as well. If I want this to cross the y-axis at 3 point something up there, I'm going to change this value. So that's kind of like the vertical shifting. So 3, perhaps 3.4, or somewhere around those lines, 3.41. Now the slope seemed to be off. So let's try to change the slope. If I do 3, it'll be too much. If I do a 2, perhaps it's still too much, 1.5. So I'm getting closer to the slope I need, perhaps 1.55, 54. So my sketch wasn't perfect, but the line is now close enough to what I need. Once I have that, I need to decide from where to where I'm going to be cutting this line. So if I use a vertical or a restriction on the range, I'm gonna cut it from here, perhaps all the way to, I would say here, or perhaps not that much. I can play around to see if I want that line to be all the way there, or perhaps I want to cut it just before that. Perhaps it looks more like a line all the way to here. So it's gonna be up to me which segment of that line I want to use. I'm just gonna use a tiny part to avoid having such a linear or a rough or stiff part of the face. So I'm gonna just use this going from 0 all the way to 0.7. So 0 and y all the way to 0.7. So that you can always use a previous graph, and this graph stops at 0.7. So that can help you see where to start the restriction on the other one. And as usual, you can always change the thickness, the color, also on the hyperbola. We forgot to change the thickness. So there we go. And the good thing about this is that because it is symmetrical, the face is symmetrical, we can always copy the line, get rid of the restriction for now, and you can change the slope. That's a good thing about the symmetrical face. And it looks like we're gonna need the same restriction. And that's kind of like a 2-for-1 deal. There you go. We're almost done with the face, but it's always a good idea to organize our work in case we want to add things. So lines or linear functions, as you want to call it, let's put those in there. And the thing here is that it looks like we only need a few more things like ellipses. We might need some circles. So in this case, I'm just gonna start working on those, and you can follow me just on screen without giving so much context of what I'm doing.